So this is College Algebra 2.3b, and we are going to continue on with example 2, solving the system of linear equations. Now what they do, you've got a couple options here, and the example in the book shows you how to do this graphically on your calculator, and I'm just going to do this graphically as or by hand. So first of all, I'm going to change each one of these to slope-intercept form, and then just graph them, and where the two lines cross is the answer to your problem. So 3x minus 4y, I'll do that on this side, equals 21. Alright, so we move the 3x because we're trying to get it in. Y equals mx plus b, remember? So I'm going to move the 3x over there, and I'm going to have my plus 21, divide by negative 4, divide by negative 4, and I get y equals 3/4 x minus 21 over 4. Slope-intercept form. So I can graph that. Alright, let's look at this one. So we've got 2x plus 5y equals negative 9, and just real quickly I'm just going to do this because hopefully you remember how to do all of this without any problem. This is old algebra. Alright, so there's that one. Okay, so from this point on, I'm going to leave it up to you, since again this is old review stuff. You've got your graph here, you graph your y-intercept there, and then your slope, and get yourself your line, and then you do the same thing with this one, y-intercept and slope, and you get your line there, and where those two lines cross, that is the solution to this. That's your x number and your y number, and that x, when you plug it in here, will work, and when you take that x, which is the same number, plug it in here, it will give you the same y. So it works for both of these equations. So rather than going through the whole thing, I'm just going to leave that for you. Alright, so this next section that we're going to deal with is solutions by substitution. Now, substitution and elimination are two algebraic ways of solving these problems, these systems of equations. Both of them work all the time, so you don't have to be like, how am I going to know when to use which one? It doesn't matter. You can use either one. The reason that there's two methods is that one of the methods is usually easier to follow or to use than the other one. Okay, so it just depends on what information they give you, what equations they give you, on which one is going to be the easiest method. But they both work. And as you practice, you'll get used to discovering, okay, because of this, this, and this, I know that elimination is probably the easier way to go. Most students will end up using elimination on a regular basis, more so than substitution, but totally up to you. Alright, so that gives us example 3. Okay, so example number 3. Suppose that the daily demand for a product is given by the formula I have here at the top, where Q is the number of units that people want, and P is the price per unit in dollars. The daily supply is given by this formula, where Q is the number of units supplied and P is the price in dollars. So notice that P is both, in both equations, price, and Q is both times numbered. If the price results in more units being supplied than demanded, we say there is a surplus, meaning we have more stuff than we can sell. And if the price results in fewer units being supplied than demanded, then there's a shortfall, meaning we are selling this stuff so fast that we are running out. We're short. Market equilibrium occurs when the supply, the quantity of items that we're selling is the same as the demand. Okay, so price and demand are both equal. We're able to keep up with the demand that people have for the product. Okay, so A says if the price is $140, how many units are supplied and how many are demanded? B, does the price give a surplus or a shortfall? And C, what price gives market equilibrium? So market equilibrium, C, is basically solving for Q and P and finding the place where both, if we were to graph it, both these lines cross, where everything is in equilibrium. Okay, so that's what C ends up doing, and we'll get to that in a minute. So A is relatively easy. We take the first one, and for P, we put in $140 and solve for Q. And that gives us how many units are supplied. And then we do the same thing with this one. We put 140 in here, and that gives us how many units are demanded. So for A, amount of units supplied is 30. The number of units demanded is 16, which means we have too many. Okay, so B, at this point, the quantity supplied is less than the quantity demanded, so a shortfall occurs. Oh, I'm sorry, I had that backwards, didn't I? So a shortfall occurs. We have more people that want this than we have items that have been produced. Okay, so because market equilibrium occurs, I'm reading C in solution, where P and Q both satisfy the system, we seek the solution to this. So we solve the system by substitution. All right, so what we have here, one of the tricks to determine if you are looking at substitution or elimination is if one of the variables is on one side of the equal sign by itself, then substitution is usually the one that's going to work the best. So if P equals 200 minus 2Q, and we have a P here, we can substitute this for P because this is equal to P. So we can rewrite this as 200 minus 2Q because that equals P, so we're just replacing P with that, equals 60 plus 5Q. You do the algebra, you find out that Q equals 20. Okay, do we know what P is? No, we do not. But we know what Q is. So I can take either one of these problems, doesn't matter which one, put 20 in for Q, and then it allows me to solve for P. And I will get P, the same P, regardless of which of these equations I substitute 20 in. Okay, I will get the same P. And that P then will be, according to what the book says, 160. So at that point, that is the equilibrium price. Okay? Or the market equilibrium, I'm sorry. It's a hard word for me to say. Okay, so bottom of page 128 gives you the solution of systems of equations using substitution. Tells you how to do it. And let's just jump to number 4 here and quickly do one for you before we move on to elimination. So we have 3x plus 4y equals 10. 4x minus 2y equals 6. Okay, if we're going to do this by substitution, on the last one I said it was easy to determine whether to do it by substitution because if you have just a variable on one side, then it makes it easy. You choose substitution. Well, this one we don't have a variable on one side. So because it said solve by substitution, we are going to pick one of these equations. Does not matter which one we use. And we can make it so the variable's on one side. Now the book takes the bottom one and sets it equal to the variable. I'm going to take the top one just to show you another way of doing it. So you have two ways, the book way and the way I'm going to show you. So I'm just going to take the top problem and I am going to solve it for x. Okay, so that gives me 3x equals 10 minus 4y. Going to divide by 3, going to divide by 3. That gives me x equals 10 minus 4y over 3. Okay, that is not real pretty to work with. So maybe that's why they used the bottom one. And that's one of the things you do. You try the top and it's like, ugh, x equals 10 minus 4y over 3. That doesn't look nice. Let's try solving for y on this bottom one. So we have negative 2y equals 6 minus, whoops, that's not a negative, 6 minus 4x. Divide by negative 2, divide by negative 2. So y equals 6 over negative 2 minus 4x over negative 2. Yeah, this is looking a lot better. So y equals negative 3 plus 2x. Or, if we want to make this look nicer, 2x minus 3. That one looks better. Okay, so that being the case, we didn't have any fractions. Now I go to the other equation, this one right here. And let's go ahead and write that in red. This is the one that we did not solve for y. And because y equals this, now whenever I see a y in this problem, I can put 2x minus 3 in its place. And there we go. I can solve then for my x. Once I find out what my x is, I take the value of my x, which in this case, when we do this, it'll be 2, and I go up to either one of these equations, doesn't matter which one, put the 2 in for x and solve for y, or put the 2 here in for x and solve for y. So when I do that, I have, when I do the algebra, and I'm assuming you can do the algebra, it's simple algebra, x equals 2 and y equals 1. And therefore my answer is going to either look like that or look like that. What this is if I were to graph those two lines that I started out with, let's go back up here. If I were to graph these two lines of these equations, where they cross would be at the point 2, 1. So if I had, I'm just going to graph them, I have no idea what they look like, but if I did this and I did this, this point here would be 2, 1, where they intersected. Okay, that's what both equations have in common, and that's the solution that satisfies both the original equations. All right, let's look at example 5. So for example 5, there's the two equations that they give you. Notice they give you two equations where they say that y equals something. So that tells me that I'm going to use substitution automatically. And I am just going to rewrite this then as, since y equals this, I'm going to replace this y with that. 0.158x minus 0.0949 equals this. Okay, so I'm going to solve that, and they're using calculator for that, a graphing calculator to graph this. If you were graphing this by hand, you would find out what x is, and x is similar to 13. And so then you take 13 in and put it in for either one of those x's, and it will spit out a y value for you. And so therefore you'd have your x and y where those two lines cross, and basically what that means is China's manufacturing and the United States manufacturing is the exact same during that particular time period, which in this case it looks like it's 2013. So your y value would be approximately 2013 when you put all that together. All right, let's look at solution by elimination in the next video.